So, David, is there any benefit to that if these highly directional beams, what's the benefit in terms of your channel planning? It seems to me that there's a logical benefit there.
Yeah, absolutely. I mean, that's a good point. I think one of the um, perhaps knee-jerk concerns when we talk about 60 gigahertz is that it's unlicensed, and what about interference between nodes, etc. But when you're actually forming links through these pencil beams, you have to remember it's actually a very constrained radiation pattern. So just forming these beams and connecting nodes through these phased arrays that do so, basically all the energy is just going node to node, and it's not really bleeding to neighboring nodes and vice versa. So it's actually a very powerful tool to help mitigate self-interference, and it also enables a very highly efficient use of the spectrum. In fact, we can deploy hundreds of teragraph nodes in a network, all using the same channel, the same 2 gigahertz channel in 60 gigahertz, in part because of this property. There was one other comment I wanted to make about it, just emphasizing something Anthony was describing about how these nodes actually find each other in this way. That's a very important part of the teragraph technology too, is sort of abstracting that complexity from the installation team, from the service provider, right? These nodes actually, after a very crude alignment, just get the nodes roughly, I think you can sort of put them within plus minus 25 degrees off azimuth, pointing at each other, which you can do without any special tools. They thereafter can find each other and form the optimal, beam between nodes to form these high capacity links. So very simple from a user or let's say installer standpoint.
Anthony, what capacity are we talking about here?
So what we're talking about is at around about 200 meters, you can get gigabit capacity. So you're going to get a gigabit link up. Now it depends on rain regions, but we have planning tools to help with that in order to maximize the throughput per range. But but again, with a distributed network, you can always bring your network closer to the users. Plus the fact using we actually have the ability, because everything's a lot smaller, we can have a very high gain antenna in quite a compact form factor now. The V3000 with a small antenna on there is got a 40-45 dBi antenna on this. Something like that in sub 6 would be absolutely enormous, just manageable.
So Anthony, let me just give you some boundary conditions here from a sort of network designer, sort of put things in perspective. So you said 200 meters, break the gigabit barrier, right about gigabit. Let's bookend that. Let's start at 100 meters, between nodes, and let's look at maybe 300 meters between nodes. If we sort of bookend it a little bit, what are we looking at 100 meters? What kind of throughput can we get if we bond all the available channels?
Well, so what we would do, coming up in the next release, we can channel bond 2 channels. So with this, the .11AY eventually will let you channel bond all 8 if you, or 4 channels if you want to. But what we're looking at with Teragraph at the moment is your channel bond 2. And at 100 meters, you can get data rates in each direction of around about 2.8 gigabits per second. Would be about the data rate you'll get.
Okay, so 2.8 gigabits per second
in each direction, uplink and downlink.
I'm sorry, what was that?
In uplink and downlink, so in total,
yes, bidirectional. Okay, good. And so that's with two channels bonded. Mm-hmm. And then the technology can actually has a roadmap path towards bonding 4.
Well, the standard allows you to bond 4, yes.
Okay.
That'll be in the future.
Okay. So is that effectively double the 2.8?
Yes, it would. Yes.
Okay. Wow. Yeah. That's some big numbers there. So there you go. So now we're actually quite a bit higher than we've actually blown through that gigabit barrier. Because I was trying to wrap my head around this gigabit link. We've been trying to get gigabit in wireless for a long time. And I really hate this sort of the consumer products, the things you buy, you put it in your home, and they have these crazy things like, AC 3400, which sort of implies it's 3.4 gigabits per second, but you'll never see more than 200 off of it. You wonder why. Yeah, so I'm always looking for that technology that's going to break that gigabit barrier, and I think this is it. This is neat. It's neat stuff.
Well, we also have clients like the V3000 though, where you will get that sort of data rate at 600 meters. So it really does depend on the gain that you have on those antennas. And as I say, the ranges, depending on the range, depending on the product, can go from 100 meters to 600 meters to 1 kilometer. We have links out there at over a kilometer getting 1.8 gigabits per second. So
you see, then I was thinking 300, 400, 450 meters as my upper boundary, but you just sort of blew that out the wall, out the door as well.
It's a common misperception, I think, around 60 gigahertz, right? That it has to be very close range, and people forget that actually, classic link budget applies. If you have higher antenna gain, you can actually budget for longer link distances.
So that's why you guys are here. That's why I'm not doing this thing on my own.